All right, good morning, everyone. It's 10 o'clock here. We're going to let a few more people join before we get started, so give us another minute or two here. All right, well, let's get started. Good morning, everyone, and welcome to another episode of the Long Coffee Break. My name is Devin Gash. I am your air distribution sales engineer in our Northern Colorado territory, covering Southern Wyoming and basically all of Colorado. Today, we are presenting on Halton and their pollution control units and their Marvel control system for their kitchen ventilation. Halton's a great brand. It's one of our premier brands. Pollution control is something you guys are going to see a lot here with these fancy restaurants and high-end condos with restaurants on the lower floors. The River Mile is going to be a big project coming up, so you guys are going to see a ton of these. They're crucial for maintaining, the comfortable, smell-free space that attracts people to these fancy restaurants. So it's really important that you guys, I think most of you know a lot about pollution control and grease exhaust and kitchen exhaust and ventilation. Joe's just going to touch base on kind of the basics and then what sets Halton apart from everyone else. So today I'm joined by Joe Coots. Coots, he's my co-presenter. He's a sales engineer and key account manager for Halton, has been there for 25 years and I think in the industry for 25 years. So I will let Joe go ahead and take it away.
All right. Thanks, Devin. Hello, welcome everyone. As Devin said, my name is Joe Coots, and I work for Halton as a sales engineer located at the factory in Scottsville, Kentucky. Halton manufactures a complete line of commercial kitchen equipment, including exhaust hoods, exhaust fans, pollution control units, makeup air units, utility distribution systems, recirculating exhaust systems, and custom controls to make it all work as designed. But today we're just going to talk about pollution control units and the Marvel control system that we have. So first off, we're going to look at the Halton product for pollution control that we call PoluStop. The objective of this system is to remove grease, smoke, and odor from the cooking process to keep it from exiting the building, or as a fire prevention tool to mitigate the amount of grease inside long runs of ducting. It's a modular system that can be assembled according to the project requirements. All right, Evan. So as I mentioned in the previous slide, the PoluStop design will be put together with individual modules that best serve the requirements of your specific project. Find out what that module configuration would be. We're going to ask certain questions about your project. For instance, is your goal to remove grease from the ductwork? Is your goal to reduce the amount of grease that's being discharged to atmosphere? What type of cooking equipment is in use and how much grease is actually being produced by the cooking process? Is odor a small concern, or is it critical to remove as much odor as possible? When you answer these questions, we have a software program that we can input that information, and it will give us the best module design for the project. All right, so as I mentioned, the unit is made up of modular components. So that's kind of what sets Halton apart. We're able to put together almost like a Lego set of individual modules that will build out exactly to your specific project. So we're going to look at these individual modules over the next few slides. So first off, if you have a project that is using dry mechanical filtration only, and by that I just mean fabric type filters that are going to absorb the grease, and they're going to be thrown away when they're full. So if you have a situation like that, we're going to recommend our ELF module, and ELF stands for Extended Life Filters. So this particular unit is made up of, as I said, mechanical only filters. It has the extended life filter, and what that filter does is it combines a traditional pre-filter and a bag filter into a common unit, which has a larger surface area, which is going to collect more grease. It's going to last longer. And that way you only have one filter to replace instead of two separate ones. Okay, if mechanical filtration is not enough, if you have a heavy grease application, we need to remove more grease, or if you simply don't want to throw the filters away, what we do recommend is the electrostatic precipitator. It is an ESP. The unit will collect grease using an electrical charge that's directed into metal plates, and then that collected grease is going to be washed away during a scheduled daily cleaning. It uses hot water and chemical to clean those plates once the grease is accumulated on there. And in this way, there's no filters to throw away. It's basically the grease is washed away with a hot water wash. So the next module that we would look at is odor control. We can do the ELF filter module and the ESP module are going to be removing the grease. So what's going to control the odor? Two different modules to do that. First off, we can do a simple deodorizer. It's like a masking spray that's injected into the airstream. And what that involves is a pump and a container of liquid deodorizer. So this pump will siphon the liquid deodorizer, pump it into the airstream. As the exhaust fan is operating, it's going to pull and push that deodorizer through the airstream and blow it to the outside. If odor is critical in your particular project, we would recommend we go to the next level and use UV and carbon. So this particular module has UV lights, actual UVC lights, and carbon panels. So the UV actually does affect odor. And in addition to that, we're going to have those carbon panels that's going to absorb the odor or the odor also. And this would be the kind of the top of the line recommendation for odor control. And of course, every unit, every system is going to have a fan, an exhaust fan that's going to actually evacuate the exhaust from the hoods. And it's just a simple motor fan setup. And one thing I want to add is to that unit, if noise is a concern, we do have a muffler basically that we can add to the end of the unit that's going to reduce those sound levels. So now that we've seen the individual modules, what I want to do is just show you some examples of typical configurations. So we're going to look at some of those over the next few slides. So this first step here is kind of a light duty. Just going to mechanically remove the grease. Those filters are going to be thrown away. We're going to have a simple spray deodorizer, and we're just going to have the fan. So basic unit, simple unit, lighter duty applications. Next up, if you have a heavier grease application like a broiler or a wok, and where odor is more critical, just some examples of steakhouse, Asian cooking. So we're going to use, or we're going to recommend the ESP, the electrostatic precipitator. There will be a mechanical filter beyond that ESP. That's just part of the package, just to remove any excess grease that's not removed by the ESP. And we're going to go into the UV lights and the carbon panels to remove that grease. And then another place that kind of sets Halton apart. To my knowledge, Halton is the only one that offers a pollution control unit for solid fuel cooking. So in a solid fuel cooking application, we're going to recommend a double pass electrostatic precipitator. We're going to recommend a double pass of the carbon filters because odor is going to be a bigger problem in a solid fuel application. So this is kind of the top of the line, all components included there. All right, so that's all about pollution control. Next up, we're going to look at MARVEL. So MARVEL was an acronym that Halton uses for our demand control system. So what is demand control? The hood exhaust is going to be regulated. The hood exhaust airflow is going to be regulated, adjusted according to the cooking status. So there's basically 4 different statuses when you're talking about cooking. The system is off, which means there's no heat, there's no cooking occurring. The exhaust fans should be off, makeup air fans should be off. Idle mode is the next step when enough heat is present that it's going to turn the exhaust fan on to like a 30% mode. What we're doing is removing heat. Somebody's turned the cooking equipment on. We just need to get rid of that heat. The next step is kind of a 2-part. It's modulating and cooking. So when cooking starts to occur, specifically with the Halton system, we have infrared sensors pointed at the cooking surface, so we know when cooking is going to occur. We know when that temperature drop happens. So we're going to go immediately to cooking mode, which is 100% exhaust. Now, we know that once the cooking starts to slow down, there's just going to be heat and some little bit of smoke present. So that's when we start modulating. We modulate between idle and cooking all day long. We're constantly measuring the temperatures and we're modulating, but we know when cooking for sure is happening, we go to full speed. So that's just kind of a little breakdown of what Halton demand control is. Let's take a look at some of the components involved in a Halton demand control. We have the infrared sensor that's pointed at the cooking surface. We have a pressure transducer inside the hood that's measuring the volume of air through that hood. We have the exhaust volume damper that allows us to modulate individual hood sections, exhaust air. And then we have two temperature sensors. One is inside the hood that's measuring what the exhaust air temperature is, and then the other is measuring space temperature. So we're using all of those inputs to generate what the output is for our demand control. And here's just an example of the principle of exhaust. We see the infrared sensors pointed at the cooking surface as one hood. Click the next slide, Devin. As one hood starts to come on, you see a little smoke rising. You can see up at the top there, the minimum max, the exhaust fan is going to start running. Click it again. Say another hood comes online. The exhaust fan is going to go a little bit higher because now we've got 2 hood sections in operation. And then finally, in this particular case, there were 3 hood sections. They're all running at cooking mode. So the exhaust fan is going to be running at full speed. So how does MARVEL save energy? So in a normal restaurant, you have a constant volume of air that's represented in the blue column there. But with MARVEL or with demand control in general, is we're only going to run when the exhaust fan needs to run, when there's cooking actually happening. So we're going to save the amount of energy that would typically, with that fan running all day long, that fan is only going to run when it needs to run. So that's where the savings come in. Just want to give you an idea of what a generic or the competition of their demand control. So their systems use exhaust temperature sensors only to send a signal to the VFD to adjust airflow. They're looking strictly at exhaust air temperature, whereas Halton is looking at exhaust air temperature and cooking surface temperature. The setting for their sensors is kind of arbitrary, and it must be set in the field depending upon what temperatures that the cooking equipment generates. The temperature in the duct is affected by space temperature, so the cooler the kitchen is, the more that temperature is going to be affected. That's why theirs has to be set in the field. And the exhaust air volume is driven by duct temperature, not appliance activity, whereas Halton system is driven by appliance activity. Their system is just not very accurate. It's not very responsive. Halton system is an immediate reaction to what's happening at that cooking surface. And then their arbitrary exhaust air temperature settings just can cause heat to spill into the space. Now let's take a look at some of the takeaways from why you want to have a Halton Marvel system. So as I mentioned, the Halton infrared sensor is the most accurate proactive method of measuring what's happening at the cooking surface. All of our hood sections are going to include volume dampers that are going to be able to individually adjust multiple hood sections on a common fan. Our system is monitoring multiple inputs. So we have a PLC in every hood. It's measuring the infrared temperature, it's measuring space temperature, it's measuring exhaust temperature, measuring exhaust volume. All of those inputs are going into the PLC, and the output is coming out with what the exhaust needs to be. Halton is going to have the highest overall savings when compared to the conventional demand control systems, because as I mentioned earlier, their system is very basic. Their one hood's on. Basically, if they have 3 hood sections, all 3 sections are going to be on, whereas Halton can individually control those 3 hood sections. And then Halton offers remote monitoring as a standard on all of our projects. And that's basically it.
Well, Joe, thanks a lot for your time. Thank you everyone for joining us. If anyone has any questions about Halton's products, please reach out to your long sales engineer, and we'll get you all the information you need, help with design. Yeah, next week I have no idea what we're presenting on. Mike, do you want to chime in on that? What are we talking about next week? I think Mike's gone. So you guys will see the email. Moving on to our coffee break gifts. Thank you everyone for your time. Enjoy the rest of your week, and we'll see you next week.